All right, number 5.
Could I get to it real quick? Can I get it that much? I sent good one. Give me about 10 seconds.
I'm just going to copy the problem while you get.
So the head versus square. Oh, this is not the
Wait, what happened?
Some kid, actually,
We were done. He was sitting on the side. We were done. Everybody was done. There was like 2 minutes left, and his phone went off, and then Mr. Freeman took his phone.
Wait, this was during. Find the average rate of change. What are we using? A-rock. All right, this is not. This is we are, but we did secant and tan line, so this will be the secant line. Yes. So they use the same difference quotient, f of x plus h minus f of x over h. But the tangent is as h goes to 0. The limit. The tangent uses the limit. Because you're wanting to get secant is just a regular line through 2 points. Tangent goes through just 1 point. Okay, not a tan graph, but if I had this parabola, this is a secant line.
It barely touches it.
Right, and there's a tan line. And as these points get closer and closer together, they approach the value, the slope of the tan line. The line starts to look more and more like the tan line. Okay, so here we go. This asked me to write an equation. No, it just asked me to find the average rate of change. So this is the x interval, yes? To find the average rate of change, I need x and y values, yes? This is saying from pi over 4 to 3 pi over 4. Because it says find the rate of change over each interval. So since it's telling you that that's the interval over which it's occurring, you know that that's the x value. So cotangent or the flip of tangent, right? And the over 4s are easy. Why are the over 4s easy? It's 4, but why else are they easy? What's the value there? What's the tangent value at every over 4? 1 or negative 1, depending on what quadrant you're in, right? So all I need to decide is what quadrant I'm in here, because the reciprocal of 1 is still 1. I'm in the first quadrant here, so f of pi over 4 is 1. So pi over 4 is root 2 over 2, root 2 over 2, right? Divide anything by itself. That's your y value. That's right. Yes, so this point is pi over 4, 1. Yes, and now I'm going to find the y value of this one. The reason then is if I think about the unit circle, right? At pi over 4, these values are the same. So if I divide the tangent value is 1. I'm trying to find cotangent, but the reciprocal of 1 is still 1. So, and all your over 4 values, if you look, they're all either 1 or negative 1, right? Depending on the quadrant you're in.
So what you're saying is basically that so 2 or 2.
Well, if I do
The next one being like the
square root of 2 over 2 divided by square root of 2 over 2. Anything divided by itself is 1.
And that's how you find the tangent.
That's the tangent, right? Yes. Yes. Yeah.
When you said find the tangent,
Alright, so the next one is a good old negative 1.
A good old negative 1. So this point would be. That's right. So now to find the average rate of change. Yes, always in radians unless specifically asked for degrees. Radians are always assumed. Negative 1 minus 1 over 3 pi over 4 minus pi over 4, which would take me to negative 2 over 2 pi over 4. Does that confuse anybody? Instead of dividing by a fraction, I am going to -2 times 4 over 2 pi, multiplied by the reciprocal. The 2's cancel. This is a lot of work. Come on, Dylan.
Okay, so when I got fractions, I plugged the answer back in and I got something. So for number 5, I got -2.
That's fine. When you flip it, you should come back to what we got. You just simplified 2 over 4 to 1 over 2, guys. Instead of dividing by a fraction, I multiplied by the reciprocal. Right, so I took the top and I multiplied by the reciprocal of the bottom. It is. Well, but so see, I canceled because it's like this. So I canceled a 2 and a 2 top and bottom. All right, part B.
Hello, everybody.
Hi, Van. Pi over 6 to pi over 2. So again, I need the y values that correspond with these x values, right? The endpoints of the interval. Remember, we're using fancy words that really just mean slope. The average value of the function over this interval is just the slope between the two endpoints. That's it. So let's find the endpoints. F of pi over 6, so the cotangent of pi over 6. So what's pi over 6? What's the tangent of pi over 6?
Oh, square root of 3 over 3.
All right, the tangent is square root of 3 over 3. So that means the cotangent would be 3 over square root of 3, right? AKA the square root of 3. Take just a moment to look at that. You could also, if you are really, really familiar with your unit circle, knowing that the pi over 3 and the pi over 6 are the same coordinates, just inverted for x and y, then the tangent at pi over 3 is the cotangent of pi over 6. If that made it. A couple of you are like, yeah, you understand what I'm saying. Some of you are looking at me like you're speaking Greek right now.
Say that one more time.
All right, pi over 3 and pi over 6 are the same coordinates, but they're flip-flop. They're x and y's, right? Do you agree with that? Look at pi over 3 and look at pi over 6, right? So it's the same thing, but the x and the y's are switched. So your tangent value, if the tangent here is, what's the tangent at pi over 6? Square root of 3 over 3. So that value is also the cotangent of pi over 3 because they're inverted. X and y are inverted. I don't know. My brain works like that sometimes. But all right. But it's not wrong to work through this way also. All right. How about pi over 2? A little bit easier to work with. What is the cotangent of pi over 2? What's the yes, do this on your own. Since you were supposed to last night.
Oh, there it is. The cotangent, that'd be 1 over cosine, 0.
This one you have to think about a little bit more. Okay, the tangent is undefined. Tangent is undefined, but what about cotangent?
It's 1 over cosine, right?
Is it?
No, it's cosine.
Cosine over sine. What's the cosine at pi over 2? What's the sine at pi over 2? So the cotangent of pi over 2. So although the tangent is undefined at pi over 2, cotangent is not undefined at pi over 2. Okay, first off, are you in radians? Hit mode. I'm going to print a poster that says, "Are you in radius?" Okay, now, cotangent. How did you do cotangent?
1 over tangent, and then plug in the value. 1 over tangent pi over 2.
Okay, so
This is error domain.
because tangent of pi over 2 is undefined. So you're doing 1 over undefined. Instead of doing it that way, do cosine pi over 2 divided by sine pi over 2.
How about someone saying it right?
Because if you divide by a known undefined value, you're undefined.
I'll put it right.
Mode. Hey, you got a fancy one.
There's still a lot of stuff on there.
Either way, I got the
Where's
same
it at?
answer.
Oh, it's
See it?
right here.
Okay.
I treated undefined as 0.
Oh, I got you. Yeah, don't do that. All right, so then my average rate of change is
Well, your average
square root of 3 minus 0 over pi over 6 minus pi over 2 gross.
How do you do?
He said, how do you do square root of 3 minus 0? Don't think about that.
It's okay. Don't pick up.
I'm just saying, like, because usually when you subtract things, they have but it's just.
Well, 0 is nothing.
I just want to make sure.
So, we would get
Yeah, negative.
Negative something pi over 6.
What's pi minus 3 pi?
The negative 2 pi over 6.
Yep. Now take the top.
Well, it's going to be square root of 3 over 2 pi. Multiply by those 6. You've already done. Sometimes I say there's no such thing as
There's my average rate of change. Today we're going to talk about using this as the
Why is there a little 3 written up there?
well, because 6 divided by 2 is 3.
Hey,
No, I didn't. Did I kill a kitten, y'all?
how can you take a 2 from the pi though?
As long as you're multiplying and not adding. See, look at the kitten. Up there, I'm adding. That's why the kitten. Do you not know what we've been talking about?
No, I just felt like the
Yeah. So everything in my life, I've done them. It's okay as long as so you're saying you did 0 minus square root of 3? That's fine as long as you got pi over 2 minus pi over 6 on the bottom. It doesn't matter.
I got a question. One question. When you did this right here, you see how that, so there was no negative on the bottom. When you multiply by the reciprocal, you leave the sign on top.
Yeah. Well, it doesn't matter where you put it.
It doesn't?
As long as you don't put it both places. 7 through 12?
I should do 7 through like 30.
Okay, so 7 and 8 are almost identical. So let me do one of those. And then you can do what? Yeah. Let's look. Is there either one of those, anyone preferential to the other? Okay. Accelerating from a standstill. So the figure shows the distance time graph for a 1994 Mustang Cobra accelerating from a standstill. You have elapsed time, and what does it say? Oh, estimate the slopes of the secant PQ1, PQ2, PQ3, and PQ4, arranging them in order. Bless you. 7. So where am I? Oh, P's at the very top. So let's estimate some coordinates here because we're definitely going to have those. At Q1, it looks like it's about 10, maybe 225. 220. We'll go with Van's 220. I'm going to say it looks a quarter of the way up. That's okay. Q2, I'm going to go with 14, maybe 390. So everybody's answers may not look exactly alike here. I think that's probably 16. Maybe 490 again. Q4, maybe 18,550. And then P, because that's where I'm going off of each time. Yes, 2650. And so you have this graph. This is one of those calculus things that makes it sound like it's so much worse than what it is. Here's P, and then these just kind of Q1, Q2, Q3. Once you dig through the wordiness of the problem, you generally find they're not asking for anything really difficult. They're just asking for something you already know how to do. Like this is the slope. It tells you to find the slope of the secant PQ1. Well, that means the slope of the line through point P and point Q1. That's it. It's above it.
There's no like.
It's up above.
Wait, hold on. It said, so it gave you all those coordinates, right?
No, you had to look at the graph. I just looked at the graph and estimated.
Oh, okay. And then it says give the secant.
It says estimate the slopes of the secants PQ1, PQ2, PQ3, and PQ4. So PQ is a segment. It's a line. So if I drew a line from between these 2 points, what's the slope of that line? Because that's a secant line. It goes through 2 points. So this would be 220 minus 650 over 10 minus 20, or vice versa. What is P and what is Q1?
Well, P just says coordinates and then Q1.
Yeah. It's just a slope between P and Q. No, that's normal. You're thinking, what? No. You're thinking a secant line just means it intersects brackets.
Every time you said secant or like.
It is a little. You're thinking about the trig function. We're not talking about trig right now.
What is it secant? What is it secant?
Yes.
What does secant mean?
Secant means it intersects the graph in 2 points.
If
you're talking about a secant line.
Oh, well that makes
right.
sense. That makes sense way easier.
We're finding the slope of the secant line.
So the slope of the line that goes through its line.
Exactly.
Which is only that.
And it asked us to do PQ1. It asked us to do PQ2. It asked us to do PQ3 and PQ4. Yes. What's another word for the slope? Average rate of change. Delta y over delta x. Same difference, right? So PQ1, I get 430. So about 43. But listen, units are really important here. Okay, and especially with what we're getting to today. What are the units here?
The units are, I don't know.
What'd you say? Meters per second. Because the graph says seconds and meters. Okay. And that's important because we talk about speed and velocity and acceleration and all that stuff. Guaranteed FRQ for sure. All right. So how do we do that? So I'm thinking that we are going to, so the closest estimate I could get using this, since I don't have a formula, would be to use the point closest to P and use that to estimate the instantaneous rate. Did y'all hear the question? So part B says estimate. So pretend like we've gone through all this. I don't know what you get for P. Somebody tell me what the answers are. PQ2, about 46, about 50, and about 50. So then, and of course these are meters per second, make sure you get in the habit now of writing these units because you will lose your answer point if you do not. It's not of times it is. A lot of times that's a separate, not just the answer point.
So you can actually just get the wrong answer.
A lot of times. That's why I say always write anything. If you look at that question and you go, I don't have any idea. Something. Right? Something. You would be so surprised at some of the stuff you get a point for.
Minus what?
How do you know you want to?
They give you scoring guides. We're going to talk a lot about FRQs and scoring guides and where you get stuff. But they don't tell you ahead of time, no, where the breakdown happens.
Who had the best score?
You'll see there's a pattern to it. Okay, so who what? I had 2 5 last year. Who was it?
Ella. A quarter. Did anybody make a four?
Didn't Ellie get one on the list?
No fours with a lot of threes. And there were no ones.
Is it like hard?
Give me a hint.
50% passes you.
I failed the living.
Yeah, it was like 56%.
My handwriting is pretty good.
All right, so part B asks you to estimate IROC at P. Right, the instantaneous rate of change. Not average rate of change, but how fast was I going at P? Well, I don't know, and I don't have an equation to use, so I can't use that limit formula. I can't use the difference quotient. But looking at it, remember, and this was really what they wanted to get you thinking. We'd use PQ4 because as secants come closer and closer together, remember, it approaches that tan line. And so what I want to use is I want to say, okay, well, PQ4 is going to be my closest estimate because it's the closest to the point. What? Where is P1? Okay, so anyway. All right, so that should help you with 8 also because 8 is the exact same thing. That's it. Well, this was not a formula IROC. That's what I was saying. We're going to say that's a good estimate. That's the best estimate we can make because that's the closest point we have to P is that Q4. So we use those two. Okay, if you wanted to. You could, if you wanted to. If you wanted to say, well, I know P is 2650, so maybe 19.9649.5 or something and find it there and wanted to estimate, you could. But you're still going between 2 points as opposed to the limit. All right, let's move on so we have time to get to what we need to get through today. All right, that was 7 and 8. What else did y'all say? We did 10 together yesterday. Yeah, 10 we did in class. That's the one we did in class as an example. Okay, so anyone in particular? I think this one again, if I do one, you'll see. Do you prefer any one over the other?
Not number 10 because we did that in class.
How about 12? Normally they're harder at the end. I don't know. 11's got a fraction. Y'all tell me, I'll do whatever. All right. I will have done like a third of your homework with you by the time we finish this one. All right, y equals 1 over x minus 1 at, more than that, because we did one from each section yesterday too. Okay, at x equals 2. So it tells me first, find the slope of the curve at the indicated point. When I see at the indicated point, my brain automatically goes IROC. So part A is IROC. So that is the limit as h goes to 0. Give me the formula. X. The limit is h goes to 0. What's the difference quotient? F of x.
X plus h minus f of x over h.
The difference quotient. Thank you. I am replacing the x's with dose because that's what it told me, not Fauci's. But
Well, don't you have to plug in?
Yes, I will. I will. Okay.
Wait.
Y'all are getting caught up in the, which is typical in calculus. That's what I told y'all in the very beginning.
You told us it wasn't the calculus that it was the calculus.
That's right. 2 plus h minus. It's the calculus too. No, it's not, Dylan. Stop. Okay, I rock the calculus.
I'd say it's clean. I don't like ROI.
Okay, let me just sidebar here so that you see where this is coming from. If f of x, this seemed to help a couple of you yesterday, is 1 over x minus 1. What is f of 2 plus h? This is the part that throws y'all every time.
2 plus h in for x, right? Oh, well, we got to find h, but yeah.
Okay, take f of x, replace the x with 2 plus h. It's not as hard as y'all are making it. It looks worse than what it is, but it's really not that bad. So this is 1 over, well, 2 and negative 1 is 1. Do you agree with that? Okay.
No, because
But
why? I thought
We got to finish out our
it's in a parentheses. How can you just?
why I put parentheses there, but addition and subtraction, I can drop these parentheses because nothing else is happening. Well, before I can finish it out, I also need to know what is f of 2. Yeah. 1 over 2 minus 1, so 1. Why am I doing all of this? Why am I not just substituting in the limit? I would have 0 on the bottom. Everybody sees that, right? It's not. That's not multiply. That's subtract.
Well, I know, but like.
So 2 plus h minus 1.
Bro, I'm so tired of those injuries. It's like posted like 20 cents.
We're not in bio. We're in a. No, now let's act.
Don't stress. It's gonna listen. All right. Well.
All right, shouldn't have taken it. Worry about this.
I was gonna say you'll pass this one.
Okay, so Miss Fisher, you want to be taking more where the x's,
Yes.
plug in that 1 over x minus h for every place there's an x.
Oh, you just took out the h.
So like you see how there's the 2, right? You say f of 2, but then on the right you're doing all this other stuff. So do you plug in that? So like right here, you see how this is f. So we know that x is 2, right? So we plug in the 2, but over here you're doing this with whatever this is.
Okay, so that was my original f of x. That was the original one given,
and
right?
then you're also plugging in 2 for x here. Then do you go back and plug what you did
Okay,
from
not
this
2 for x, but I plugged in 2 plus h for x here.
Okay.
And then I plugged in 2 for x. So what I'm going to do, this becomes this, and this.
And then you stick them back in there?
I just kind of evaluated them off to the side because everybody was getting confused on where everything was coming from. All right, I'm going to do 1 over 1 plus h. I'll give you a little brain break after we finish going over homework. Minus 1 over h. I am going to do my same little trick of multiplying by the reciprocal rather than dividing. Okay, hold on. All right, look, f of 2 plus h, here, that's here. F of 2, here, and here. Just subbed in, that's all I did. It looks worse than what it is. Whenever it clicks for you and you see what it is we're actually doing, we're not doing anything astronomical here. Like this is not, don't let it blow your mind because, okay, remember, I'm still finding the limit as h goes to 0. I still cannot plug in here because I'd still have an h in the denominator. I'd still be undefined. So let's do 1 over 1 plus h minus 1 times 1 over h.
I mean, can we put the first part of the one?
Yeah, it's for the culture.
So like 1/1 plus h minus 1 all over 1 times 1.
For the culture.
Is that how it works or how?
So you know, just multiply by negative h over 1.
No, wait, okay.
Just distribute.
She's being asked a lot of questions.
Just multiply over negative h over 1.
Look, just distribute 1 over
For the culture, dude, culture 2.
h plus h squared minus 1 over h.
Culture 2.
Flip it. You start to flip it. Yeah.
What number is it? Hold up. You still got it. You see this? You see this blasphemous? I got that for the culture.
We should come back to the same thing. As long as you followed rules and I follow rules, we should come back to the same simplified fraction. So,
Distribute the 1 over h.
this distributes to both pieces in the bottom.
What about the 1?
Not for the culture. Not for the culture.
Put it over the.
But I need a common denominator here to combine these. Right? I want it to look like this. This is really h times h plus 1. It's got an h. I need it to have an h plus 1.
Oh, yeah.
Okay?
So now you only have an h down there.
Notice this is no longer calculus. I am just algebraically manipulating, combining fractions, going through trying to find a common denominator. All right, so I have 1 minus h plus 1, because 1 times anything is itself, over h times h plus 1. Are you all okay there? This one? That's what it was originally. Okay, so here I had, do y'all remember when we did LCDs in Algebra 2? And I had you come over here and I said, write the LCD, and we factored the first one and we said, what is this one missing that this one doesn't have? And we gave it to both of them. No.
This is just a lot of work.
Wait, hold on. You can't cancel out the h and h plus 1 on the left side.
No.
Yeah, well, I know, but you only have one.
But I'm not done yet, because this is going to be to the point where I can cancel out. Because if I do,
You only wrote 1 down there, though. Like, you only wrote 1 set of h plus 1s.
where?
On the denominator.
Here?
No, the denominator down. There, yeah, there.
Because what happens when you combine fractions with the common denominator? If I have 2/3 plus 1/3, it'd be 3/3. So you leave the bottom the same, right? That's what I did. I left the bottom the same. Combine the top.
So you're multiplying that.
Yes.
I am so confused.
All right. If I have 1 over h times h plus 1 minus 1 over h, and I need them to have the same denominator, what can I give the second fraction to make it look like the first fraction? An h plus 1. But if I do it to the bottom, I also must do it to the top. Okay. So now look what I have. I have 1 minus h, and this minus is subtracting everything. So it's going to be minus 1. Now the magic happens, because the 1's cancel. And I end up, yes. But I have, this is negative h, so be very careful. And listen, you could have gone about it a different way. That's what I was telling Meg. As long as you follow rules, there's not just one way to do
I don't
it.
think I followed any rules. You just.
But That's what you have to do. You got to find common denominator. Now I can sub in, yes? Remember, that's the whole point. I'm trying to get to where can I sub in. This was a long problem for an IROC problem. All right, so this is, if I put a 0 in here, I end up with -1/1. So the average rate of change here, nope.
-1/1 is -1. I'm tired of this. It's always some simple answer like that.
That was part A. That was part A. Y'all hear what I'm saying, right? That was part A.
It is always
Just part A.
That's why the homework takes me so long. It's like 5 parts.
Okay,
They
but
all take 30 minutes to do.
this part, all right, so this part was, IROC is also known as the slope of the tangent line at 1, which is -1, right? So part B says, what's an equation of the tangent? Well, so what do I need to write the equation of a line? I need a point and a slope, right? I have both of those. Scroll back up here. Here's a point, right? You agree with that? Because I have to go, it says at x equals 2, so I need to use that point. So f of 2, we've already figured out, was, what was it? I just, 1. I have a slope, I have a point. Let's write the equation. 1. This is the tan line. It's the equation of the tan line. How about the equation of the secant line? What is the the normal line, I'm sorry. Normal. Negative reciprocal slope. All right, this is what you missed yesterday. The slope of the normal line is the negative reciprocal of the slope of the tan line. So if the slope of the tan line is -1, what's the slope of the normal line? So it's just 1. So what's the equation of the normal line? Same point. Nope, same point. Y minus 1. The only thing that's changing here is this.
Okay, so it could be.
Tan lines of piecewise functions. I told you y'all would love it.
Who was doing math and decided, hey, this would be fun. This would be fun to make.
Fauci.
Fauci did that?
Fauci
did not do that.
Yes, he did. He came up with piecewise. You didn't know that? The one with the, yeah.
Did he actually come up with these?
Yeah, look it up. Sometimes they don't call it piecewise. They call it All right, tan lines of piecewise. I'm sorry. It's not, man. He did. I'm just kidding.
Doesn't even do that.
Okay, we're not getting into that debate. We've done a lot with piecewise as far as it with the limits left. As we approach from the left versus as we approach from the right. So we're gonna we're gonna do the same kind of thing here, but I want to talk about how we know that we have the possibility of a tan line, right? Because some places are not going to lend themselves to have a tangent. In other words, if I have some type of piecewise function that looks like this, it's going to be kind of hard for me to have a tangent at this point, right? Yeah, that would represent the whole function, right? Because it's discontinuous. That's exactly right. So you hit the nail on the head with part of it. In order to, for the possibility of a tangent, and I'm not going to say that this allows, every time you have these scenarios, possibility of tangent, it doesn't mean that there is necessarily a tan line. It means I have the possibility. It means if one of these does not exist, I can automatically say it does not have a tangent at that point. And so the first thing, that's exactly what y'all just said, is I need it to be continuous. So how do I check for continuity? What's the definition of continuity? Okay, give it to me in limit form.
The limit as x approaches from the left is the same as the limit as x approaches from the right.
Which is also the same as?
No, A. Oh.
The limit from the left is the same as the limit from the right, which is the same as the function value at that point. Because that hole's got to be filled in right there also, right? I can't just have an open hole. I can have a hole and the limit could be the same approaching, but then have the point defined up here, and it's not continuous. So limit from the left has to equal the limit from the right, which also has to equal the function value. Okay, so it's got to be continuous, or it should have a slope. Mm-hmm. And for this, I'm going to put your biggest thing is to check left and right sides, because I'm talking about piecewise. Kind of, yeah.
I mean, it might
Also be
unless it has an exclusive point in it, right?
Right.
Well, then how does it? Well, then it would have a slope. Way I would.
Let's look at an example. These are always easier, I think, to look at in the form of example, and we are going to be using the difference quotient for these. What's the difference quotient? And because I am talking, well, we'll just leave it there. But whenever I start talking about IROC, I'm doing that. The limit is h goes to 0 on that one. Okay. This is number 16 from your homework. You already did it? I was going to say, you jumped ahead a night. Well, he developed piecewise, so.
I can't erase that either. Don't let you erase that. That's just the copy of the bill on the board.
continuous or what else?
Has a slope.
You write it slow to your girlfriend. There we go.
So I want to know, determine whether the curve has a tangent at the indicated point, and if it does, give its slope. If not, explain why. So obviously I'm going to be looking at x equals 0, because that looks like it could possibly be my point of discontinuity
How do you
here.
know what point to use?
It gave it to you. It said at 0. I could have probably guessed that, because that's where the function is piecing together at 0. Ask me, Van, what were you saying? How do I win?
Well, there is a slope, negative x.
So how do we determine? Here's how we're going to determine.
Parabola, and then you got a slope.
Let's see if the left equals the right at that point. You want me to graph it right now? You don't have to graph it now.
All you do is plug negative x, that slope to the left of 0, and to the right. And
Okay, but remember, I want to do difference quotient.
graphing that piecewise. I'm pretty sure they are equal.
Yes, you'd put the 0 in, and then you'd put like negative 1 in. That's fine. So, yes. So, left hand and right hand, right? And if they're equal, I should be good. Are y'all all okay there? All right, so, okay, go ahead. F of x plus h minus f of x over h. That's difference quotient, yes? All right. So as I approach 0 from the left, what does that mean exactly?
That means that it's going from negative to correct.
But if I'm look, I'm in a piecewise situation. So if I'm approaching, this is my f of x, right? And I'm doing it at 0. They tell me what to use it. So my x is 0, right? I need them to be the same. No, because I'm doing the left-hand limit. Remember, as it approaches. So it's not necessarily the function value. Now, I'm going to need it to be the same. If I find f of 0, I'm going to need them to be the same to test continuity. Right. So as I find this one, I'm the limit as h goes to 0 from the left. Well, 0 plus h is just f of h. Do you agree with that?
I agree with that statement.
Okay. So this is just negative h. Are y'all okay there? Minus f of 0 is just 0. F of 0 plus h is the same thing as f of h. If f of x is negative x, then this would just be negative h. F of 0 would just be 0. The x in the original equation was negative. Okay? Okay. So the left-hand limit is negative 1. Are we all okay there?
Now you see the right hand limit.
Okay. Check the right. Y'all try that one. Try the right-hand limit. See what happens.
Harder.
That is harder. It is harder. I'm sorry, Dylan, but I know you can do it.
Let me ask
I know you can. Yes. We are still using 0, but
the bottom thing is
always coming up with those.
so f of
Hold on, just shut your mouth for a second.
That's f of h. Which is what we were hoping, right?
How do you get negative 1?
h squared minus h over h.
Say that again. While this cancels, it's a 1.
Square. So
Yeah.
put square in that one right there.
Yes.
Wait,
Because h times negative 1 is minus h.
oh, that's what you did. Can you do the balance? Because I think I plugged it in wrong.
I didn't FOIL it out because 0 plus h is h.
Now, where do you go from h minus 1 over 1?
All right, look, f of 0 plus h is the same thing as f of h, which is h squared minus h. Because f of x, when I'm approaching from the right side, is x squared minus x, right? No, you don't. Don't say that.
Yeah, it is. Yes.
Right? So this is where this comes from.
So you have to plug that in after you plug in the 0 for x.
I'm
Well,
sorry.
you're plugging in.
Okay, Van, you don't have to. It's just less work this way. If you kept the x in there, you'd end up foiling out. And then you'd end up putting 0 in.
You can only do that though because it was 0, right?
Right. Otherwise, you'd be in a position like Van saying where you'd be foiling.
You just plugged in for h.
Correct. Correct.
All right, so now what? You're at H minus 1.
And if you put 0 in at h minus 1, you get negative 1. Okay.
I'm trying to explain it in the way that it'll work.
I think we're supposed to plug in every x for this. So for
Yes.
this one, where is it? Oh, this one. So for every x you plug in.
Okay, when you cancel this, it's not canceling, it's making a 1 there, essentially, is what it's doing. Every other time we've had a coefficient in front, and the h has gone away, but h divided by h is 1. So this is really h minus h, or h squared minus h, so it's h minus 1.
So wouldn't that just be h?
H minus 1 would be negative 1. Plug the 0 in for, you see what I'm saying? Okay,
So was I right up to this point?
yes.
And then when you get here,
But
you
this
can't
is
cancel
minus
out.
h because of this negative in
So
front.
right here, you're telling you can't do that.
Well, so you can, since these cancel,
Mm-hmm.
right? So you end up at this point with h squared minus h over h, right? And so you tried to cancel an h out of everybody, and you can. But what happens here is it doesn't become 0, it becomes 1. Because this is the same thing as h squared over h minus h over h, right? I could split it up that way. This would be h, this would be 1. Be careful when you cancel, because the coefficient stays. The coefficient's just 1. All right. Left hand limit equals the right hand limit. I have one more check
So
to
you
check.
have a tan line. There you go. You did. That is a tan.
Yeah, it may not be continuous though.
Well, it is.
So what is f of 0?
Well, f of 0.
Well, where is it defined for 0?
Maybe 0 minus 0.
This equation.
So that's 0. No, 0 minus 0
Is 0.
They define it over 0, 0.
No, it's an exclusive point.
Okay, but
What is it?
remember what I told you?
Or,
Yeah, I know. That's why I was saying.
Yeah.
Oh, yeah, it's high.
So it does have a slope. So it does have a slope because the left and the right side match. Yes.
Now, what we were looking for is for f of 0 equal to.
Right. So even though this is not continuous there, it did have a slope because the slope from the left equaled the slope from the right. They were the same.
okay, well, how do you know it's
This would be discontinuous because they don't share that same point. Like it's not continuous there because the limits as you come from the left and the right are not the same. Wait. No, don't write that. The slopes are the same as you come in from either side. Are the limits the same as you come in from either side?
Yeah, that's why I was thinking the function is different.
What's the limit as x approaches 0 from the left of f of x? This is different than the difference quotient. What's the limit? Because remember, this is how we define continuity. So what's the limit as x approaches 0 from the left of f of x? As it approaches 0, though, so I can sub in there, so it's 0. What's the limit as x approaches 0 from the right? Now I'm using this equation. It is. I'm sorry, I told you wrong. That's what I was saying. I told you wrong. The slopes are the same. They both have a slope. The slopes are the same from both sides. So it has a slope.
So why do we
It
just?
is negative 1. It is.
So why do we just
Negative
go
1 is
other
the
limits?
slope, and that's different than the point of continuity. The slope has to be the same from both sides.
Why do we write limit?
Wait. I-rock is split between 2 points. I-rock is split at a point. Sorry, I got that mixed up. How did the limits just go from negative 1 to 0?
We were like, we
Okay.
started with limit.
Difference quotient is IROC. Yes? This is finding slope. This is looking at continuity. And those are two different things.
So what the question asks us to do?
Does it? Well, if it's continuous, it's going to have, it's more than likely going to have a slope, a tan line. And then,
Well, what is the question?
Like, how do we know that the continuity is there? Like, how do we find that?
well, it said at 0, and this is the break here. So the question is the value the same, the limit the same from the left and the right, and the function value the same? That tells me if it's 15. What tells me if it has a slope or not is if the difference quotient is the same from the left and the right.
0 and find the continuity.
Yes. So let me write this for you, and so you'll have continuous or not. And you is the limit some value from the left is equal to the limit of that some value from the right, which is equal to the function value at that point. What we were doing was slope of tan, which is IROC, right? This is the difference quotient. From the left and right. If these are the same, that's the slope of my tan line at that point.
So when we were doing the limits on the function, we're seeing if there is a tan line.
Right. Right.
And then we found slope of the tan line. So it probably should have gone the other way around.
Check continuity first, yeah. Yeah.
Because then if there wasn't
But remember, it's an or situation. And it's giving us the possibility.
So like the other or says if it's a slope. We found out there's a slope, so I have to check.
But if you are given a piecewise, they will want to see that you check the difference quotient from the left and the difference quotient.
We found that, so why would we have to do the other one?
Because we were getting confused. Whenever I slipped up and said continuity, and then somebody said, wait, I thought, and I was like, yeah, you're right. I messed up. So I wanted to clear air. I'll show you on the graph real quick. I am wanting to see this anyway. If I plug in 0 here, plug in the endpoint, I get 0, 0. It's exclusive. Plug in a point less than 0, so maybe 1, negative 1. Sorry.
Negative 1 will be 1.
Positive 1. So negative 1, 1. It's going to go this way. Here, plug in 0, you get 0. It's inclusive. Plug in 1 bigger than 0, so 1, and I get 1 minus 1, which is.
No, you get 1. If you plug in 1, for x, then you would get 1 squared minus 1. Sorry.
What happens if you plug in 2? Let's do something different. So, yeah.
4 minus 2. Well, you could do the other one next. You can see the hard.
Yeah.
Oh, yes, it is continuous.
What's happening here, the reason we were getting that same value there, and it would have looked like this is actually dipping down. The vertex here opposite B over 2A. So the vertex is happening here at like 1/2, and it would be somewhere like here. That's why we were plugging in 1 and you might think that that's a line, but we knew it was a problem. But that's why that.
I forgot why that was.
You did a whole video.
No, I didn't do the video.
Well, that's why you don't remember it.
Yeah.
All right, let me talk to you about a couple things, and I'll shut up.
I don't know. What year was that? Sophomore year? there's definitely a reason.
English, if I had Crowley the same time
I
I had
have a
me.
certain Dizzo. I have a certain Dizzo.
Miss Quillen was brilliant. She would make us fight for a 99.
Yeah.
Like like a Hunger Games. She'd be like, okay, corners.
It was like a bell ringer assignment, and she was like, only one person gets 100.
I just want to walk you through how to approach these problems because, again, it's wordy, but what you have to do is not that bad. All right, so for 28, it says rocket launch. At T seconds after liftoff, the height of a rocket is 3 feet squared. How fast is the rocket climbing after 10 seconds? So T seconds after liftoff, the height of the rocket is 3t squared. How fast is the rocket climbing after 10 seconds? So when it says after 10 seconds, I'm looking for an instantaneous speed here. Okay, I'm looking for the speed at 10. It says after 10, but it doesn't say what's the average speed over the first 10 seconds. What's the speed it says after, but it's like asking at 10 seconds. So this is an IROC situation. Okay? And it gives you the equation, and it gives you the t value to use. Okay, y'all okay there?
Okay.
Number 30. Ooh.
Wait, this would be, do you think, like, can we, with 28,
I want you, what?
So we plug in the 10. So that would be 300. And then what do we do from there?
0, 0. And you'd find the slope between those two.
That's A-Rock.
That's A-Rock. He asked, let's pretend it was A-Rock. But because it's I-Rock.
So what do we do now? We plug in 3t squared for h. Oh, okay.
I would do this as algebraically because that's what you're going to have to show with your other stuff. So in other words, f of 10 plus h is 3 times 10 plus h squared. And f of 10, I'm just replacing these values here. I'm just doing it off on the side.
How did you not plug in 3 for f?
This is getting confusing because they used h to define here. This is really f of t. It's t squared. 10 squared would be 100 times 3 would be 300.
You gotta foil that.
Mr. D, do you like Clash Royale?
So, do you distribute this one?
No, FOIL first. And then distribute the 3. I'm going to leave y'all to that one because I think y'all can handle it from there. Okay. It would be
Yeah, because 3 times 10 squared. Well, the equation's 3t squared.
sorry.
What is 300?
So it's 60h. Nope, it's 60 plus 3h, and then you put the 0 in. And that, of course, is in, I told y'all I wasn't doing this one for you, and we did it anyway, meters per second. Nope, feet per second. Number, what? Number 30, you need to know the volume of a sphere equation. Do you know how to find the volume of a sphere? No.
IR squared.
9 times out of 10, they will say, given the volume of a sphere is, find the rate of change of da 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 da. All right, so the volume of a sphere is, but we will do this one so many times, you'll remember this one. 4/3 pi r cubed. So 30 says, what is the rate of change of a volume of a sphere with respect to the radius when the radius is r equals 2 inches? So you're looking for rate of change, and since you're talking about r equals 2, so just think they've just changed the y's to v's, the x's to r's, and you're still in your difference quotient. If you want to put it in terms of what we've been doing, f of r equals 4/3 pi r cubed, or you could do f of x equals 4/3 pi x cubed when x equals 2, knowing that x is really r. X is your radius. Don't forget your units there, which it says is inches. If it's volume and how it's changing, rate of change of the volume would be inches cubed per inches. We'll talk a little more about that tomorrow, just so you know. There's 2 more I want you to think through before. I want to just make sure you can. I don't want you to go on your homework and be completely lost. This is difference quotient again. 32. I know, I'm sorry. I know this is boring. I can feel it. I feel like I'm being monotonous. I'm sorry. The equation for free fall at the surface of Jupiter is S equals, I hope you're seeing a pattern with these problems. Meters in t seconds. They do. Assume that a rock is dropped from the top of a 500-meter cliff. This is a lot like the Wyatt problem, right? Find the speed of the rock at t equals 2. So again, this is our I rock. The only difference here is this. On your test, it was 16t squared. Now it's 11.44t squared. Right?
We have a calculator for that?
Yes, that's the calculator problem.
Is that?
You started. What do you plug in?
And it says t equals 2. And then you do the same thing, the difference quotient. F of x plus h minus f of h.
I have a question.
Okay.
It feels like sometimes we use f of x plus h squared.
It depends on the original f of x.
So how do we?
I would not ever do that again from this point. I would use the algebraic way now. If you're using a table and you can use your table to go 0.01, 0.001, 0.0001, but the more that was just to let you see that as h gets smaller and closer to 0, that's what happens. From now on, I would definitely do it algebraically.
That's good for info and value.
Like, so, Mr. Geek, can you tell me one more time how we done it with? How do you know when to use?
If there's a squared in the original function.
All right, all ready to go. Do so.
All right, wait. Let me show you this one thing. I know. I'm sorry.
It's horrible. I'll get back to you.
And then lit's way better than pi also. And pi is the easiest one.
This is going to ask you a little bit backwards. You got to think.
First of
At
all,
what point is the tangent horizontal? What does that mean? What does that mean? Something is 0. You're exactly right, Katie. What would be 0 if it's horizontal?
Horizontal, as you said, 0 is in the bottom.
The normal one.
No, that's vertical.
No, Katie was like something equals
Other
0.
X or Y is 0. I think Y is 0.
Why?
Where are you horizontal?
The next is 0.
Okay, listen again. At what point is the tangent to this graph horizontal?
0, 2, pi.
What am I looking for? I'm looking for where the what? 0.
Well, you're looking where the
Yes.
where the tangent is 0. You plug
So
in
this
0.
time,
Plug in 0.
where does that equal 0? And you'd have to solve for x. All right, that's all I got for you today.